Let's assume we're given this kind of problem which says the coefficient of kinetic friction between two blocks, which is shown in this image. We have 2 kg on top, and beneath here we have 3 kg. And we're given mu k to be 0.30. And the surface of the table and the pulleys are frictionless. The first question asks us to draw a free body diagram for each of the blocks. Here we have 3 blocks. This is 10 kg, 2 kg, and here we have 3 kg. Part B, it asks us to determine the acceleration of each block and find the tension in the string. And notice that here we have T1 and T2. So first thing first is to start with the first one, which is 2 kg. Let's start by drawing the free diagram. So notice that here we're going to have a point, an arrow pointing upward, and here we're going to have another one which is pointing the right hand side. Here we're going to have the left, last but not the least, which is going to be pointing this side. And notice that what we have on top is what we call the normal contact force by 3 kg on 2 kg, which can be written as Fn, normal contact force, by 3 kg on 2 kg. So what we have here is the friction between, that is this point, which is friction between 2 kg and 3 kg. Let's write it this way by saying friction between 2 kg and 3 kg. And what we have beneath is simply going to be the weight of 2 kg. And here is going to be our tension. And I think we are done with the first part, which is this. Let's look at the second diagram, which is the 3 kg. In this case, let's start by putting in the 3 kg. And here also we're going to have different points or arrows pointing different directions. The first thing which we have on top is the normal contact force by the floor on 3 kg. Contact floor force, normal force, we can put it this way, by 3 kg, right? And here is going to be our T2, which is the tension, which is in this particular direction. So next is going to be down, which is force on 3 kg by 2 kg. Let's put it force on 3 kg by 2 kg. And here we have on the left, which is going to be our T1, moving this side, and this is the T1. The last but not the least, which is going to be the one with 10 kg. So here we have, this is how it looks. And notice that here we're going to have an arrow which is pointing upward. Our T2, which is this, the one pulling it upward this side. Here we're going to have our T2, and downward our weight is going to be 10 kg. So this is it for part 1. So the next thing which we are asked to find is to determine the acceleration, which this is what we're going to look at now. Alright, so first and first, from the given values which we are given, or data rather, we are given M1, which is going to be our 2 kg or 2.0 kg, and we are given M2 to be 3 kg. Our M3 is simply going to be our 10 kg. And the mu k, which is the coefficient of kinetic friction, is given to be 0.30. So first thing which we need to do is to find the kinetic friction. In this case, we are going to look at the normal force between M1 and M2. Then that will enable us to find the kinetic friction. So how can we do that? If we set normal force, basically we're going to focus on this particular point, which is the M3. So notice that this is going to be our normal force, which is Fn, is going to be mass multiplied by gravity. But notice that if this is M1, the N is going to be N1. If this is M2, the N is going to be N2. So let's continue. We're going to say Fn normal force is going to be, let's put it N, which is going to be M2 multiplied by the gravity. In this case, what is the value of M2? M2 is going to be 3 multiplied by 9.8, which is going to be 24.4 in newtons, and the answer is going to be 24.4. My apologies. If you punch on your calculator, it's going to be 29 instead of 24. It's 29.4 in newtons. So second thing is to find the kinetic friction, which is going to be mu k. And the formula for this is going to be, Fk, is going to be mu k multiplied by normal force. In this case, the mu k we are given to be 0.30. We're going to multiply that by the normal force, which we are given to be 29.4. If you multiply the two together, we're going to end up with 8.82 in newtons. So second thing is to form an equation of motion. This is going to be our T minus Fk, and this is simply going to give us acceleration, mass and acceleration. And notice that we have problems in M1, and we have in M2, and we have in M3. Setting an equation for the M1, this is simply going to be T minus Fk, which is going to be M1 multiplied by acceleration. In this case, this is going to be T minus, what is Fk? Fk is given to us as 8.82 in newtons. This is going to be 8.82 equals to, what is M1? M1 is 2 multiplied by acceleration, which is going to be 2a. Notice that this is negative and this negative is attached to 8.2. Our value of t, if you switch the direction, is going to be positive. It's going to be 2a plus 8.82. Feel free to write this one down. So moving to the next one, we have set an equation for M1. So let's set another equation for M2. In this case, this is going to be T2 minus Fk, which is going to be M2. We're going to multiply that by acceleration. Our T2 is going to be T2 minus, what is Fk? Fk is 8.82, which we have already defined the value. And what is M2? Our M2 is going to be 3 multiplied by acceleration, which is the same thing as saying 3a, because we haven't found the acceleration yet. So this is the same thing as saying T2 minus 8.82 is equals to 3a. This is negative. Moving it to the right hand side is simply going to be positive. The value of our T2 is going to be 3a plus 8.82, and this is it. So notice that from the diagram which we are given, if you could remember, here we have our M3, which has what? The value of 10 kg, isn't it? Let me write it nicely. Which has the value of 10 kg. We're not going to use exact equation as this to solve the M3. Instead, the M3 is going to be M3. It relies or depends on gravity, which is going to be M3. We're going to multiply that by gravity. And notice that here we have T1, then somewhere T2 here, we are going to minus T1 minus T2, which this will give us our mass and then the acceleration. In this case, the value of the M3 which we are given previously is 10. Multiply that by 9.8, and I'm going to minus T1 minus T2 to be equals to M3, here we have 3, to be equals to M3 multiplied by acceleration, which is going to be 10a. So at this point, we can now substitute the value of T1 and T2. Notice that what we have at T1 is 2a plus 8.82. Therefore, 10 multiplied by 9.8 is simply going to be 98 minus T1 minus T2 to be equals to 10a, which is the same thing as saying now we can replace these two values, which is T1 and T2. 98 minus we're going to put a large bracket, let's say 2a. From the inside also, we're going to close that, plus 8. I'm just substituting the values now, 8.82. So now we can go ahead and substitute the value of T2. And what we are given at T2 is going to be a huge bracket of bracket into 3a. We're going to close that by the bracket of 8.82. Close the bracket, and at the end, what we are going to be left with is your 10a. So now we can collect the like terms. Notice that here we have 2a and here we have 3a. And what we have in between is plus, and here we have plus. Here is going to be 98 minus 8.82 plus 8.82 minus 2a plus 3a, which is equals to 10a. So if you plus 8.82 plus another 8.82, what are you going to be left with? This is simply going to be 17.64. Therefore, I'm going to have 98 minus 17.64 minus 5a, because 3a plus 2a is going to be 5a, which is simply going to be 10a. So, collecting the items at this point, which is going to be, if you minus 98 minus 17.64, the answer is simply going to be left is 80.36. Here we have 10a, negative, moving it to the other direction, which is simply going to be 10a plus 5a, which the answer is going to be 15a. Therefore, we're going to have 80.36 rather, which is going to be 15a. So a is the acceleration, and our final answer is going to be 80.36 divided by 15, and your acceleration is simply going to be 5.36 in meters per second square. So now that we have found our acceleration, let's go and see all the known values now. So notice that we're given M1, M2, M3 and the rest, and we had a conclusion previously. We said our T1 is 2a, and we're going to plus that by 8.82, and we said our T2 is bracket of 3a, and it's going to plus that by 8.82. So now that we have gotten our acceleration to be 5.36 in meters per second square, we can now simply substitute it by saying T1 is simply going to be 2 multiplied by 5.36. We're going to plus that by 8.82. And your final answer for this part is simply going to be 19.5 in newtons. So what about the T2? So what we are given in T2 is this. In the case of T2, we are given, which is bracket of 3a and plus 8.82. And our acceleration is given to be, 5.36 in meters per second squared. So in this case, our 3 multiplied by 5.36, and if you plus that by 8.82, your final answer for T2 is simply going to be 24.9 in newtons. So this is it for this problem. If you find it helpful, please just do me a favor by subscribing to Germanic Science. See you next. Let's assume